Venus, the brightest star in the evening sky, has captured our imaginations for centuries. Its thick, swirling clouds have never allowed a camera or telescope to glimpse the surface below. Since August of 1990, though, a spacecraft named Magellan has peered beneath this veil of mystery to show us the surface of Venus in unsurpassed detail. The secret of Magellan's success is a sophisticated radar instrument that operates with incredible speed and efficiency. During a burst of activity that lasts less than 1 second, Magellan acquires imaging, altimetry, and radiometry data. This information is used to make images of the Venusian terrain, to determine the heights of surface features, and to measure the microwave energy that is naturally emitted from the planet. Magellan gathers data for approximately 25 minutes during each 3-hour orbit around the slowly turning planet. Starting at the North Pole and moving south, Magellan maps in swaths or strips that cover an area about 16 miles wide and nearly 7,000 miles long. Twice during each orbit, Magellan turns its dish antenna toward Earth and transmits the data it has just acquired. While this happens, engineers on Earth track the changing motions of the spacecraft to learn about Venus's gravitational field. The large antennas of NASA's Deep Space Network receive the stream of data from Magellan, then transfer it to NASA's Jet Propulsion Laboratory. Computers process the data into 15-foot-long image strips. These strips provide the first look at what Magellan has discovered. Additional processing of the strips reveals exciting and sometimes puzzling details. A massive lava flow that appears to come from the rim of an impact crater. A 4,000-mile-long lava channel that is unequaled in the inner solar system. And an unexplained jet-like streak associated with another impact crater.
Magellan has given us a more detailed view of Venus than we've ever had before. Needless to say, all of our scientists and their students are thrilled, not only with the quality of the data, but by the quantity. We've returned more imaging data from Magellan so far than all U.S. planetary missions combined. We've begun to use some new evolving computer technology to combine the images with altimetry data and make simulated flights over the surface of the planet. Let's take one of those excursions now.
Our flight begins at 3 impact craters. The largest crater is approximately 40 miles across, about the size of the Los Angeles basin. The bright rims were created from debris that was thrown out when huge meteorites hit the surface. Moving southeast, we pause to observe a small volcanic caldera, then rise to focus on Alpha Regio, a highland region in the southern hemisphere that spans 800 miles. The circular feature at lower left is a corona. These features are found only on Venus and are thought to be volcanic in nature. Now we descend for a closer look at the complex terrain of Alpha Regio. Our path then zooms east over jagged ridges to a volcano with a fluted rim, unofficially called the Tick. Our journey through Alpha Regio continues over hundreds of miles of rugged territory. Turning northeast, we leave this tortured area and head to 7 pancake-shaped domes. These volcanic eruptions rise up to a half-mile above the surface and average 15 miles across. They may be made of thick, sticky lava. Such domes have only been seen on Venus. Our flight then continues to the west and ends near the rim of an impact crater.
I think you'll agree that this is a pretty exciting way to look at the data. But more importantly, it gives us a way to compare the relationships among the surface features. I'd like to mention at this point that the color we use is taken from an actual photograph from a Soviet probe that landed on the surface of Venus in 1981. And now let's continue the journey.
Straight ahead is Sif Mons, a volcano that towers more than a mile above the surface of Venus. As we approach its sprawling base and climb to slowly circle the peak, many lava flows and other scars reveal the volcano's violent past. We turn south to look at another crater. Then a quick flight to the east brings us to the mouth of an extraordinary 600-mile-long rift valley. We arrive at another volcano named Gula. Here we skim its mile-high summit and descend to view the lava flows and ridged terrain of its northwestern face. A volcanic caldera now in sight is further evidence of Venus's active geologic history. We now turn east and follow a dark streak of unknown origin that leads to two impact craters and a lava flow that has traveled many miles from its source. Looking northeast, we ascend for a panoramic view of the area just explored, the western portion of Isla Regio, an elevated zone in Venus's northern hemisphere.
The last part of our trip takes us over Artemis, a broad, sweeping canyon that's of great interest for geology and geophysics. This canyon is so beautiful that it would be a tourist attraction if it were on Earth.
Although Magellan completed its first mapping cycle in May of 1991, its exploration of Venus will continue for several years. An important strategy for the extended mission was to change the angle of the spacecraft so Magellan can record a different view of the surface. Will Magellan's multiple observations of Venus reveal changes in the surface features? Is Venus, like Earth, still an active planet? These and many other questions about this intriguing planet are likely to be answered as current and new generations of scientists analyze the legacy of data provided by the Magellan mission. Venus is often called Earth's sister planet because they are similar in size, mass, and distance from the Sun. What Magellan teaches us about Venus will undoubtedly help us to understand the similarities and differences of all of the members of our solar family.